Alright, time for the DraftPhysics.com video presentation. So, physicist Michael keeps using terms like model testing. And sounds good, but regular conventional physics doesn't really do it. And they claim, that other models fail the test, but they don't account for their own failures to meet test standards for their own theory. So it's almost like the Feynman idea, where Richard Feynman, in one of his presentation shows, in one of his show videos, actually plays with sage gravity and points out how, well, yeah, it meets all of these criteria, the model fits, except for the one idea where they don't, he's not provided anyway an explanation for the drag that would be created if space actually had physical energy in it. And really because no one figured out an explanation. So yes, so it gets 99% of the criteria fits and 1% fails, therefore move on, And it doesn't matter, though, if they have a theory that doesn't explain anything. I mean, it doesn't have any it's not a physical explanation, their model. It remains completely untestable because it doesn't say anything about what will physically happen. And somehow that's an acceptable model because, it doesn't, it is essentially a religion, a God theory, something you can't test. So I have on the Debate Physics channel put 12 5-minute videos that could be responded to by those who say what I'm talking is nonsense, but so far nothing. And these are all test failures, in my opinion, for the things they are contending. So I guess I will go over some of those now. And just point out all of the unanswered questions, all the questions about how spaceships move. I send something with twice as much or 4 times as much or 2,000 times as much energy out one side of the spaceship, for example, a bullet. And I have the recoiling gun go out the other side. What's their contention? That the 2,000 joules, the 2,000 watts of energy don't have any effect, and somehow they're the same as the 2 joules. I mean, again, these are demonstrable failures of their theory to show any test successes. So in all this time arguing this, I mean, there is a point where they, this 1/2 mv squared has a clear implication. I have to get rid of this thing, I believe. And then this is just not in the right position. And it's close enough. Alright, so, I have explained the history. They won't even talk history at all. They won't even acknowledge the history of these formulas and these statements they're making about reality. So there's this difference in understanding. A transition took place in human understanding where in the beginning this is what they believed in. Something simple, mass and velocity decided how much energy something had, how much it was going to impact you, depending on how big the train was and how fast the train was moving, and that's all you really needed to know, and you know how much of a mess it would make of you, and so over a period of 100 years or so. Around the 1700s, they changed it into this thing, okay, 1/2 mv squared. And the squared term here implies that all you have to do is increase something's velocity, and you can make a huge impact on its impact. So you can reduce something's mass, increase its velocity, and you'll get more energy out of it, or you'll be able to put more energy into it. You'll be able to store more somehow. And then this ends up being related, because they do their little math tricks, to some sort of notion that if you hit something like a brick wall or a heavy thing, very massive thing. Okay, and you manage to create a reflection. That is, the thing bounces back with 100% of whatever it started with. That I put 200% of that energy into the other object. Now, I've pointed out with a video called the ball bearing bounce, okay, that if you have a hardened steel, so you can have two kinds of steel, and you could do this ball bouncing thing. You just take a ball bearing and bounce it. So if I don't have tempered steel, that is, if I don't make the steel hard by quenching it quickly, that is, cooling it very fast, I don't get, I get 10 bounces, and if I do harden the steel, I'll get 200 bounces. And the bounces will be incredibly conservational, in the sense that the amount of distance the ball will fall will be infinitesimally small, okay, and all of it will come back just about. So the less it's bouncing, it's almost as if the more it will give back, the less it will lose to air resistance, all this other stuff, so it'll really keep going. And what you can see on the surface, so if you look at the surface of the steel, this unhardened steel actually does dent, okay, it gets a bunch of little bumps in it, little defects in it, and that's the reason why this steel doesn't bounce very well, is because it does in fact deform the steel. And the difference here is it doesn't deform the steel, it's hard, so there's no losing of the energy to reshaping the steel. And clearly the argument that somehow you could get 200 bounces here, which, even if you started, you figure the first bounce is high and then it gets less and less and less and less. The fact is that you'd argue that in 200 bounces you're probably going to get 25 times, 25, well, gee, that is not all that visible. There's always something. I keep complaining about this always something thing, but yeah, it does show up, this always something thing. Alright, I'd be back. Alright, that's better. Okay, so you're saying that there's, when there's 200 bounces here, you're figuring that you're probably putting 25 times, okay, by their theory, by this, somehow the momentum goes into the big object, the non-moving object, and somehow it moved the whole Earth. And you're saying that, yes, you put 25 times the energy went into the Earth because the ball bearing bounced. I mean, I'd say that's a failure of this test, okay? It's failed the test to be a reasonable statement that somehow with each bounce the ball bearing is actually putting energy and moving the Earth, because it doesn't make any sense. So, and it does, kind of prove the theory that, the important thing is the MV thing, and direction doesn't matter. It doesn't matter which way momentum is going, whether it's going that way or that way. There's no plus or minus energy. And so it's also a challenge against this notion that somehow momentum is vectory, whatever that would be, and that kinetic energy is scalar. It's some sort of scalary kind of energy, that somehow it doesn't have a direction. When each example, there's clearly directions involved. The kinetic energy of the ball bearing is in a direction, so I mean, why would you say it's a scalar and it's not a vector like anything else? I mean, it's just nonsense. And such. So, we'll go to some other examples, but I mean, clearly it's failing this test. It's failing to be a credible statement to say that the energy of the ball bearing, each time it goes down and hits, that the reflected energy is somehow almost meaningless, okay, in the sense you don't need to account for a source for it because it's in the opposite direction somehow, and that you're getting twice the energy into the object you just hit. So you really have 3 units of energy. You have the unit of energy that got the ball going back the opposite way, and you have 2 units of it going down this way. Is that really something people should believe that's realistic. So with each bounce, 2x goes in here, 2x goes in here, 2x, 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 2x. Come on. No, that's a test failure. Alright, so another argument, okay, about this increasing energy is that they're basically saying that, you know, if something's going twice the velocity, okay, then it has, alright, 4 times the energy. Alright, and that means you need 4 times the fuel, okay, to go for twice as fast. And somehow going twice as fast will mean you will make 4 times the mess. And then you can just change this to, you know, 3, and then you get this 9 number. 9 times the fuel to go 3 times as fast. Okay, and that would equal 9 times the damage, you know, 9 times the impact. Now, it just gets worse and worse, right? So we could do 6, you know, 36 times the fuel to go 6 times faster. Come on. Alright, you're going to be 36 times the energy out, you know, the watts. Yeah, 6 times the spring compression, 36 times the wattage you would get out of it. None of this has been shown in any experiment, so they can't link me to any experiments that prove this, okay, except really tiny little niche experiments, you know, with an air track where they, you know, make a 1-mass cart, you know, turn into a 3-mass cart with somehow it has still 2/3 the velocity. But outside of those tiny little examples, all the other experiments point the opposite direction, in the sense that it just basically shows that you don't need this, and that if you understand how the world works at all, I mean, in terms of understanding that there's always circumstances. So I've used the example of, you know, the 4-to-1 example, where, you know, they could do this with higher velocities, but they don't. You know, they could do it with a 1-to-3 or 1-to-5 and show these examples. But, you know, I can just give objects the velocity, and you can just demonstrate, okay, that things like friction are very poor tests. This is a very poor test using distance. How far does it travel? Because the test is under uneven conditions. The friction that this will experience will be different than the friction this experiences right here. So the first stage, going twice the velocity, you're going to have half the friction for a good portion of the journey. And the only thing that's going to be the same is this right here. So when the ball gets here, it'll be going 1/2 its speed. All right, just a fact. So 3/4 of the travel, and now it's going half the speed. So it's doing this velocity here. So this is identical to this experiment. These two are the same experiment. And this is the thing you're saying, well, what's this? 3 times the distance. Well, what it means is merely that you only got the same friction. You got the same amount of friction here. Okay, the same amount of work was done here. Work on the ground. The ground shook, the ground heated, the ground did all that stuff. The same amount here as it did here. So over this whole distance it did the same work, the same heat, the same dissipation, the same extraction of the energy. So you took half the energy here and you took the other half here. Very uneven. And really understandable though. And that all you really had was 2 units of energy. You didn't have 4. Yes, you went 4 distance, but you didn't create 4 in terms of wattage. You only got this is only twice as hot. Okay, the surface only got twice as hot here than it got here. That's all. So this is a test failure. I mean, if what I just pointed out here is what actually does happen, and I'll assert that it actually does happen, and they'll have no experimental evidence showing it doesn't happen, that's a test failure. That it's not passing the test. You're not showing that you're doing 4 times the work. You're not showing that there's 4 times the energy. You're not showing any of this. Okay. So related to this is the 10-ton train, 5-ton train scenario, where they I shall leave some of that just for the fun of it. You combine a 1 mass with a 1 mass, so you have 1 mass with a 1 velocity. I always do that. We'll make it a 2 velocity. All right, and you combine it with just another mass, another 1 mass, and you end up with a 2 mass. Okay, with a 1 velocity. All right, so that part we all agree on. That's what you end up with. So you have more energy here, twice as much energy in this object than you had in this object. So you lost half the energy. Now they'll say a bunch of stuff happened. They'll say, well, a bunch of work was done on the environment in the sense that things got hot and pieces broke off. Now you conserve the momentum completely. So you have the same momentum here that you started with here. Okay, exactly the same momentum. And yet they're going to say you did work, but you didn't use any momentum. So you use 0 momentum, but there's a piece flying off somewhere. Let's just say it breaks into pieces, and that's where we're going to lose the energy. Well, how can these pieces be going in these other directions, carrying away momentum? They have momentum. They're flying off, going places in space. They have momentum. Well, how did they get momentum if I didn't use or didn't lose any? How can I not lose any momentum and then give stuff away? So no matter how they're saying, no matter how you do this experiment, you can't do it and conserve the kinetic energy. For some reason, it's impossible. Right? So you have this extra kinetic energy. Let's say you have 400 joules here, and you can only get 200 here. You can't do this experiment in some way where you don't lose half the energy. And it's always half. So isn't that just a test failure? Isn't it just showing that that's just a figment? And that, no, the fact is you can do the experiment very carefully. You can combine the 2 objects and lose just the tiniest amount of MV. End up with 99.9% of your original momentum. And you might make a tiny little sound that'll count for 0.1%. You might make a little tiny noise, you might make a little tiny vibration, a little tiny shudder, so you'll lose a little tiny percent. So again, it's a giant test failure. Their theory tested, fail. Fail, fail, fail. Dismal failure. They show nothing. They show no evidence. So again, you have car tests, they smash cars into each other and into brick walls, and the cars don't show the 4 times the energy. So I go 100 miles an hour and 50 miles an hour, and I just get half. I don't get 4 times the energy, 4 times the crushing, 4 times the anything measured, and they could go to 3 times the speed and they don't get 9 times. So all of this fails all the time. It fails common tests all the time. And they've had 300 years to show us some sort of good test, and they can't do it. I can say, please show me your evidence. Show me your links to the experiments that prove this theory. And they won't do it. And they won't respond. And they won't, again, you turn the argument to a 5-minute video, and they won't counter it. They'll just say, no, you failed our test. When the test should be agreed upon that, all the experiments count, and what you have to do is account for explaining them. So unlike, it's like the Ryan Gosling guy who, he did the clay experiment, didn't come out his way, so he didn't film it, didn't show it, doesn't have to account for it. Doesn't have to explain why it failed by showing the experiment and then showing what the big failure point was, why the results were wrong, why they were deceptive. Well, anyway, so that's where we are. I'm just, people, arguments do get contentious, and it's unfortunate, but it's no, I don't see how you avoid that when, again, physicist Michael keeps claiming that this alternative theory has failed the test when his theory, the theory he's defending, has failed numerous tests and has never taken any tests. They've never tested their theory. They won't test it. They won't put it to the test. All right. And I can't call that something other than just dishonesty. I mean, when you don't have any evidence and yet you're claiming it's this proven theory, and then you sit there and give tests to the other theory that you won't put your own theory to, I mean, it's just so, dishonest, frankly. Alright, so I guess that's enough. So, the point is that they're just really unfair. So we all should agree that these models should be well tested, thoroughly tested, and clearly they just have a double standard about who has to survive the test and who doesn't, and what tests have to be done or should be done, or all of that. And it's just clearly very unfair in the fact that they don't really have to produce any evidence, and any opposing theory has to prove not only their theory's failure, but their own theory's success. And it's just a obvious, duplicitous double standard.